equations. Today we're going to start looking at word problems with systems of equations. So our goal today is to understand word problems involving numbers and speed, distance, time, and solve them with a system of equations. So we're going to start with speed, distance, time problems. And here's our little formula that's helpful to remember here. The distance is equal to the speed multiplied by the time. You may have seen in science class a triangle that looks like this. And that triangle is helpful for writing formulas that involve distance, speed, and time. So distance is speed times time. If we wanted to figure out an equation for time, time would be distance divided by the speed. All right, so from that formula, you can get the other two relationships by rearranging a chart. By rearranging, period. A chart can be used to organize the information and allow you to create two equations. Use let statements to assign x and y to the variable you're trying to solve for. All right, so you guys have had some experience with word problems before. We're going to start by assigning variables to the things that we are trying to solve for. So we're going to look at the end of the question actually to start with here. So at the end they're asking how much time is spent on the gravel roads and how much time is spent on the paved roads. So we're going to say let x be time on gravel, and then we'll let y time on paved. All right, and then it mentioned up above setting up a table. So to set up the table, we're going to do this. When it's a distance, speed, time problem, the top of the table is going to be distance, speed, and time. And along the side, it's going to be the two different situations. So in this question, two different situations are part of the trip is on gravel and part of the trip is on paved. And then at the bottom here, we'll have the total. So now we're going to fill in information that we've got from the question into our table. Right here. Killing me. That's better. Okay. So I'm going to fill in the variables first. So x is the time on gravel. So time on gravel is x, so x was there. Y is the time that they're on the paved road. So y is going to go there. And now we'll read through the question to fill in the rest of the information. So it's 230 kilometers to drive to Cam's Cottage. Part of the trip is on gravel roads at 50 kilometers per hour. So that's the speed on the gravel. That's kilometers per hour. So that's going to go there. Part of the trip is on gravel roads and part is on 80. So the 80 kilometers per hour is the speed on the regular paved road. Okay? The total trip takes 4 hours, so the total amount of time, our time's in hours here, the total amount of time is 4. We don't worry about a total speed ever. And the blanks here, I can fill in the total distance. That's in kilometers. The total distance is 230. So the formula is what I need to use to figure out what goes in these other two spots. And as we set up above, distance is equal to speed multiplied by time. So that means that I've got 50 and x here. So the distance traveled on the gravel is going to be 50x. And then I've got 80 and y here. So that's going to be 80y. And once I get here, now I've got this part here makes one equation, and this part here makes another equation. So if we want, that's going to be equation 1, and that's going to be equation 2. So I'll write it over here in equation form. So that means that 50x plus 80y equals 230. So that's equation 1. And then I've got x plus y equals 4. And that's equation 2. At this point, we can totally forget about any of the word problem stuff and just concentrate on solving this system like we've been doing for the last week or so. So if I get those two equations, I could use substitution or elimination. So if I want to use elimination here, I might multiply equation 2 times 50 so that I create 50s in front of the x's. So if I multiply equation 2 by 50, I'm going to get 50x plus 50y equals 200. And I'll call that equation 3. And now I can copy down equation 1 beneath that. So to eliminate the x's, I'm going to have to subtract these equations. So equation 3, subtract equation 1. So 50x minus 50x is gone, 0. 50 minus 80 is going to be negative 30y. And 200 minus 230 is going to be minus 30. So if I do minus 30 divided by minus 30, I get y equals 1. So then I can sub y equals 1 into, and equation 2 is going to be much easier. So it's going to be x plus 1 equals 4. So x is equal to 3. So I've got this value, and I've got this value. And once I've solved the system, now I have to go back and think about the word problem. So at the end of the word problem, it said how much time is spent on gravel roads and how much time is spent on paved roads. So remember, x represents the gravel, y represents the paved. So at the end, we got to write a statement here. So therefore, 3 hours on gravel roads and 1 hour on paved. And that's our final answer for that one. All right, so we'll take a look at another speed, distance, time problem. So the school soccer team traveled 150 kilometers per hour to a tournament by bus. The bus drove at 90 kilometers per hour most of the way, but was delayed by a storm when its speed was only 30 kilometers per hour. If the trip took 3 hours, how far did the bus travel in the storm? Okay? So they're only asking how far the bus traveled in the storm. So I'm going to say let x be distance in storm. And that means then y, so let y be distance that was traveled not in the storm. Okay, so now it's a distance, speed, time problem. So I'm going to set up my table. So I've got distance, speed, time, and the two parts of the trip. One is by storm, and one is not in the storm. Okay? So really, to figure out what we're putting on the side here, we're using what we've got for our variables in our let statements. Okay, so now I'm going to fill in some information that I know. So the school soccer team traveled 150 kilometers. Okay, so that should be, that's a typo. That should be that they traveled 150 kilometers to a tournament by bus. And that's kind of important because that represents the total distance. The bus drove at 90 kilometers most of the way, but was delayed by a storm when its speed was only 30. So when they were traveling in the storm, the speed was 30. When they were traveling out of the storm, the speed was 90. And again, we don't need a speed total there, okay? If the trip took 3 hours in total, so that's 3 there, how far did the bus travel in the storm? So I need to fill in my variables. So x is the distance in the storm, and y is the distance not in the storm. So to figure out time, I'm going to draw my little triangle here with my d, s, t. So if I'm trying to figure out what t is equal to d over s. So to figure out this expression here for the time when they're in the storm, we're going to take the d, which is the distance, and divide it by the speed, which is 30. And for the time not in the storm, that's going to be y divided by 90. So just like we talked about before, we've got one equation here, and we've got one equation here. So I've got equation 1 and equation 2. Okay, so I'll use my information in my table to write my two equations. So one equation is x plus y equals 150. That's equation 1. And then I've got this one that has fractions in it. That's y over 90 equals 3. And if you remember the last topic we covered, we handled questions where we had fractions. And what we want to do is get rid of the fraction. So I'm going to take equation 2, and the lowest common denominator in 2 is going to be 90. So I'm going to multiply equation 2 by 90. So it's going to be x over 30, y over 90, and it's really important that you multiply each term in that equation by the lowest common denominator. So a lot of times students will forget to put the 90 over here with the 3, so you got to be careful of that. And remember, we're dividing things out. So 30 goes into 90 3 times. 90 goes into 90 once. So if I move up here, so I've got 3x at the start there, plus just a y, and then 90 times 3 is going to be 270. So I've got that equation. That's going to be my equation 3 now. And I'll rewrite equation 1. And these ones are already set up. I've got y and y there. So I'm going to do equation 3 subtract equation 1. So 3x minus 1x is 2x. The y's eliminate each other. And 270 minus 150 is going to be 120. So I can solve that. So I get x equals 60. Remember, x is the amount of time they traveled in the storm. And if I look at the end of the question here, that's all they wanted to know is, how far did the bus travel in the storm? X represents the distance in the storm. So in this case, I don't have to even solve for y. I can just finish with, therefore, the bus traveled 60 kilometers in the storm. All right, last one. I'm going to leave this one. We've already gone on long enough. These questions do take quite a little bit of time, so we'll do the number problem at the beginning of class tomorrow. Thanks.